Okay, so today it rained after 50 degrees Celsius and it was a bit of a relief. I'm gonna close this a bit so that you won't have more noise. So, what we do? Oh, I find my IC. Okay, I thought I lost it. Oh, great. So, I pulled a new IC here. Okay, so that's a bit crazy. I thought I lost this IC. Okay, so it was here. Okay, today what we did is we basically designed the Benito style 8-bit register, and there is still some problem going on with this green LED. As you can see, this is basically the bus right now. So I'll walk through it everything here, and today it's a bit relief. So I made the video and I completed these two circuits. I actually completed this one earlier, which is the A register, and I'll walk through it what this is. As you can see, so this is 74LS173N, which is basically the 4-bit register. It's a D flip-flop, or you can even say the D latch. So what exactly latch means is latching means kind of hooks. So it hooks on a value, a particular thing. In our case, it's going to be either one, it's a high voltage, or a low voltage. So this is what basically we're trying to achieve with this IC. And then there are 4 bits also here, so it's a total of 8 bits. And then there is this a buffer, a tri-state buffer, and it is basically 245 74LS245. And what it does, it acts as a buffer, so you do not have to worry about being open the output all the time. So what we're doing here is basically we have the inputs for the registers and we also have the output for the register. So here these two being assigned here, and at the same time, as you can see, they are connected at the same place. So whenever you're sending a value, you can use a particular direction of this IC. So wherever you want to traverse the data in bidirectional, as a bidirectional IC. So what we're doing here is we also loading the value into the register, and we also sending the value to the bus. From the bus, we also loading and unloading. We're doing both basically just from one single IC here at 245. So these are the 4 lower bits and these are the 4 upper bits, if you can see a little bit clear. So these are 4 lower bits here, where's my finger, okay, and these are 4 upper bits, and these two total makes 8 bits. So right now the circuit is at off state. I did just turn on, the clock is going on, and here is basically the instruction register which I have to implement yet. So these this is basically how this entire structure looks like. And now let's do the load wire. So this is basically for loading the value into the register, and this is an enable signal to basically send the data whatever we have from the register towards the bus. So we're gonna load the value from the bus right now, and as you can see, I'm gonna put it to low, and at the next clock cycle it just didn't load it. Okay. Oh god, why? There is some discrepancy which is also going on, so I'm gonna put this to low, and it should have taken the value. I don't know what just happened. Oh god, it was, wait, it was working. Wait, I have to pause. Okay, it is working. It just took me around 10 seconds. I don't know what happened. So the circuit is going on, and I have put this one IC, this one basically 1 bit at a lower value, a 0. It is connected to the black wire. So if I just load this value on the rising edge of the clock pulse, it has loaded the value, and this one is at 0 since I have made that at 0. And if I just close this, if I unload this, if I just deselect the load signal, I can now freely have this value persisting in my register. So now we have the 8 bits here, and as you can see, it's 1 1 1 0 1 1 1 and 1. But now if I wanted to send this back to the bus here, all I have to do is to just enable the signal and the flow would start. And as you can see, the flow is here and it's basically 0. There's something going on with the register. I have to look here the wire connections, which is pretty okay. And this is the same how the A register worked, and the B is here. Now for the instruction register, the 4 bits are going for instruction, rest 4 are going to be other parts for tracing. And yeah, so basically it is working. As you can see, it's just at this, and we are now able to have this. And as soon as I disable the signal from the IC, it would go off, because by default these ICs are at on state for the output, and you don't want the output to be all the time connected, because then it would start to sync and it would start to send, which makes it more confusing on the bus. So what you want is you want to just entirely disconnect it at the moment. So whenever you want to send a data from the register, you basically want it to have to enable it from the 245, which is a tri-state buffer. The tri-state, the third state is being connected with this wire, which is the enable signal, which is basically acting as a switch between the on and off. Again, a third state, which makes it not on and off but connected and disconnected. So this is what that enable signal is doing. And the load signal is basically just load whatever the input wires are being fed, either a high voltage or low voltage. That's how you're going to store that value to the 8-bit registers. And with 245, that's how you're gonna send from the 245 register towards the bus. So this is how basically the computer works. It basically communicates with each other. So what we're gonna do in the future is we're gonna send these values to here, basically using the same bus, and these wires are going to be here connected, and then these values could be stored via the load signal. So whatever the value would be on the bus, basically we have to enable from here, and we have made these values available towards the bus. And for these registers to able to have the values, what we have to do is we have to just make the load signal high. So whatever the values would be there would be copied to these registers. Then we have to just off the load signal and the enable signal also, but we first have to close the enable signal, then we have to close this load signal, and then we will be able to have these values over here. And that's how entire register and computer communicates into this entire memory segment. So this is what this video all about. So